Hi guys, it's Miss Hastings. So for today's video, we're going to be doing 8 problems where you need to write in correct scientific notation. So before we get started, just a reminder that when you're writing something in scientific notation correctly, the decimal number needs to be a number between 1 and 10. And then you always put times 10 for every scientific notation. It has that, and then you put an exponent. Now your exponent will be positive or it'll be negative depending on which way you move the decimal and depending on what the number is. So let's go ahead and get started. Our first number is number 9, and it is 48,900. So that is a very big number. So remember, if you like looking just for big and small numbers, this one's a big number, and big numbers have positive exponents in scientific notation, okay? So first we need to figure out what we want to make the decimal. So we know it needs to be a number between 1 and 10. And right now, the decimal is sitting here. It's just invisible. To make this a number between 1 and 10, we need to move the decimal between the 4 and the 8. So that means we're going to be moving it left. So let's count and see how many spaces we need to move the decimal. 1, 2, 3, 4. We move the decimal 4 decimal places to the left. And that gives us 4.89 times 10 to the 4th power, positive 4. 4.89 times 10 to the 4th power is how you write this big number in scientific notation. Okay, if you want to use the ID rule that we talked about in class, that's another good way to try to think about how to make your exponent positive or negative. When you, say on this one, we moved the decimal left 4 decimal places, so that means I increased my exponent by 4. So it went from 0 to 4. You can remember it by remembering that in the ID rule, the I, which means increase, is on the left, and the D, which means decrease, is on the right. So you can use that if you want to. Okay, so let's look at number 10. This is 0.000009, and this is a very small number. Okay, now small numbers have to have negative exponents in scientific notation. So let's see what we have. So right now our decimal is here. And to put this in scientific notation, it needs to be a number between 1 and 10. So we're going to make this into a 9. So I'm going to move the decimal right here. Okay, let's see how many moves that is. 1, 2, 3, 4, 5, 6, 7. So that gives me 9 times 10 to the power of negative 7. This one has a negative exponent. Okay. Number 11. Number 11 is written in scientific notation, but it's not written correctly in scientific notation, meaning this decimal number is not between 1 and 10. So we need to move the decimal to make it to where it's a number that's between 1 and 10. So right now it says 0.63. I'm going to change it to make it 6.3. So I'm going to move the decimal here. Okay. So now this is where you definitely need to use the ID rule, because we're going to be moving the decimal right 1 decimal place. So that means we need to decrease the exponent by 1. So we moved it 1 decimal place, so we decrease by 1. Okay, so we go write 1. Remember that decrease is on the right side, so I decrease the exponent by 1 like this. So my exponent is 1, so decrease is the same thing as subtract. So subtract it by 1. That'll give me 6.3. Keep the times 10. And 1 minus 1 is 0. So your exponent actually will be 0 here. We're going to do a couple more of those, okay? Alright, number 12 is the same. So for number 12, it's in scientific notation, but it's not written correctly in scientific notation. So like this 33, not a number between 1 and 10. So we're going to have to use the ID rule to move the decimal and then either increase or decrease the exponent. So let's see. Right now the decimal's here. To make this a number between 1 and 10, we would need to make it a 3.3. So that means we would have to move it left 1 decimal place. Okay, when we move left, that means to increase the exponent. So we moved left 1, so we increase the exponent by 1. Okay, so we have a 3.3 because we moved the decimal, and then we have a times 10. We move the decimal 1 space left, so we increase the exponent by 1 digit. Negative 3 plus 1 is negative 2. So that's how you put this in correct scientific notation. Okay. This one is not in scientific notation, so we need to put it in scientific notation. And this is a very small number, so the exponent will be negative. It's 0.000216. Okay, so we want to make it a number between 1 and 10, of course. So that means we're going to have to probably, well, not probably, definitely, make it between the 2 and the 1. So it'll be 2.16. Okay, so let's move it. Right, 1, 2, 3, 4 times. So 2.16 times 10, always. And our exponent here is going to be a negative 4. Okay. Alright, 14. This is another small number. So the exponent will be negative. Needs to be a number between 1 and 10, so we'll make it 4.2. So let's move it 1, 2, 3 places to the right, and we get 4.2 times 10. The exponent here will be a negative 3. Okay, 2 more. This one is in scientific notation, but it's not written correctly in scientific notation. We would need to make this one into a 1.5. Not 15, 1.5. So I only needed to move the decimal 1 decimal place. So I went right. So I decrease the exponent by 1 number. So negative 2 decrease or subtract 1 gives me negative 3. So times 10 to the power of negative 3. Okay, last one, 4.8. Okay, now 4.8 is already a number between 1 and 10. So we don't even have to do anything here except just put times 10 to the power of 0. That's all you have to do. This is already a number between 1 and 10, so we don't need to move the decimal at all. So you can just put times 10 to the power of 0, because times 10 to the power of 0 is the same thing as saying times 1, because anything raised to the power of 0 is just 1. Alright guys, I will see you either tomorrow or Thursday, depending on what class period you're in. I hope you guys enjoy your half days, and I will see you tomorrow.